So the very first embedding that we are going to talk about is also known as Word2Vec. It learns from the context which is there in the sentences, right? So let's start and we'll see how things are trained. The first thing that you will see is it tries to find the meaningful relationship by reading a massive amount of text data, right? And after reading this massive amount of text data, it can find embeddings. It can represent the embeddings in a vector space, high dimension vector space, in such a way that the king and queen are quite related to each other, quite close to each other in the entire vector dimension. Puppies and dogs and laptops and puppies and dogs are close to each other. In the vector space, and laptops and desktops are close to each other, right? Now how exactly does it learn or creates this kind of an embedding? So what you'll see is what it does, let's take an example, right? So for example, if I have a sentence known as the dog dash fast, right? And if I ask you to identify the missing word, you'd probably say run or move or moves, right? The AI learns in a similar way, or the Word2Vec learns in a similar way. The key idea is that the word that appears in similar context gets a similar vector representation. Now, instead of treating the word as isolated symbols, the Word2Vec learns the relationship between them, right? So, for example, in CBOW or TF-IDF, they were treating it as isolated words, right? And then giving you a frequency of it and or giving you a TF-IDF sort of score of it, right? But the Word2Vec will learn the relationships between the words that are present in the entire corpus. So, for example, if I have the cat sat on the mat and the dog lies on the rug, what you will notice is that the cat and dog appears in a similar context, right? So that's why they must be related. So therefore it represents it in such a way, the Word2Vec will represent it in such a way that the meaning from the raw text gives you the context of the word that it is being used into, right? So for example, it will try to represent cat and dog. Looking at a lot of sentences, it will try to represent cat and dog in a vector space where they come close to each other, right? Let's now try to understand how exactly is this done, how exactly is it trained, right? So there are two methods of training. One is known as the skipgram model and the other one is known as continuous bag of words. Now again, you remember we have already learned bag of words. So let's try to understand what these training approaches are, right? So in the skipgram model, the basic goal of your training is that given a word, you need to predict the words which is around it. So for example, if I have an input word as dog, as you see in the example, you need to predict the surrounding words. The runs fast, right? So the sentence would be something like the dog runs fast. So given an input word dog, you will try to identify the surrounding words, which is the, runs and fast, right? Now, how exactly does it work? If dog appears very often with barks and runs, then the Word2Vec will learn that the dog is quite similar to puppy, right? And not bananas, right? Because puppy will also bark and run in a particular sentence. So you will see that okay, the Word2Vec will learn that the dog also barks and the puppy also barks, so therefore they might be quite similar or quite related, right? And that's how it will represent it in such a way, the embedding in such a way that the embeddings of dog are quite close to embeddings of a puppy instead of embedding of a banana. So this works good for small data sets, but as you can see, right, for given a single word, you need to predict the surrounding words. So therefore, it will take a lot of time to train basically and converge to a global minima. So that's the reason why you will always see that the skipgram model, it will basically be very computationally expensive to train. But if you have a small corpus of data, where you want a specific domain based sort of learning, you can use a model such as skipgram for creating your Word2Vec. Now let's move on to the continuous bag of words, right? The second way of training Word2Vec. So this is just opposite to what we did in the skipgram. In the skipgram, you gave an input word and you predicted the surrounding words, right? Here, the goal is to give us surrounding words and predict the missing words. So for example, the dog dash fast, right? Now the model then predicts run or move. Now how this particular training works is that the AI learns that the dog is more likely to go with run than flies, right? So therefore now you can see that we are giving it context, and based on the context, the dog and fast, right, based upon the context, it's trying to predict the word that should fill in the blanks basically. So this would be much faster to converge and to train than the skipgram, right? Because ultimately the model has to just predict the word based upon the context which is given, and then find the embedding, learn the embeddings out of it, right? So of course this would be faster than the skipgram, but it would need a larger data set to converge. You understand why, right? So now both of these methods produce a similar kind of word embeddings, but what you will see is skipgram works better with the rare words, right? Because what you're trying to do is you're trying to predict the contextual or the surrounding words based upon an input word, right? And then what you see is your AI will now understand the relationship between words and not just give you a score based upon the count or based upon the frequency of the words. It basically gets the essence of the words and the relationship between the words themselves, that which one would be more related to which word and which word is farly not related to something. Like, so for example, how dogs would be related to puppies and how dogs will not be related to bananas or flies, right? Something like that. So now the AI will get a better intuition or better understanding on how to basically segregate words, and that's where these embeddings were more powerful than just a TF-IDF or a bag of word kind of a model that we had discussed in the previous sessions. So we'll take one more embedding, which is glove embeddings, in the next video, but till that time, share it with someone who might like it.